So I keep my mouth shut and I listen. Afraid I lose you if I didn't. Can we find what we're missing and compromise? So I keep my shoes home and not leaving. We're on thin ice, winter season. Can we find a single reason not to say goodbye? Oh, if I said what's on my mind, would you stay with me tonight? If I said what's on my mind, would that make you run and hide? Run and hide. Run and hide. If I said what's on my mind, would that make you run and hide? Would that make you run and hide? Run and hide. Run and hide. Oh, would that make you run and hide? Don't know what to do anymore. I'm out of options, nothing's working. I'm out of service. Come help me now, I'm fucking nervous. I'm trying but can't scratch the surface. So I keep my mouth shut and I listen. Afraid I lose.
on, we realized that this approach is it's not a transition from 0 to 1. And we decided to continue the research. I started my PhD. The topic of my PhD was scalability solutions with the focus on direct metacyclic graphs. And essentially, Waterfall was a result of my PhD research. Again, currently, it is a result of the work of our entire research and development team. But initial idea was coming from me, and then it was on multiple times, on multiple levels, improved by the brilliant colleagues I am proud to work with. Apart from that, I also do some work for IEEE, and also I am advising the government of one of the countries on implementation of their Web3 strategy. This is it on my end. I'm passing it over to Yevgen.
Thank you. Hello, everyone. My name is Yevgen Leonchik, and I am an associated professor with a PhD in mathematics at the Odessa National University in Ukraine. I'm also working on IEEE projects. My main research focus lies in mathematically modeling complex computer and economic systems. I've contributed to numerous international scientific studies in this field. For the last 7 years, I have focused on the field of distributed ledger technology and have been involved in various projects concerning both decentralized, public and private networks. So I have worked at Waterfall for over 2 years in the research team, and I am pleased to be here to respond to your question about our projects. Thank you for having me. Thanks. Please, Alex.
Hello, my name is Alexander Nashevan. I'm development team lead on Waterfall project. I have master degree in computer science. And I am working in development for 15 years and on blockchain and other distributed ledger technology. I am working about 7 years. Also, I started working with Sergey and implemented his idea about Lockdown 3 years ago, and for that time I am working on Waterfall. So also I have I am a member of LTP group for current payment transaction. I have open source lead member in this group. So it's short introduction about it.
All right, got it. That's a great introduction, and happy to know about you all. And yeah, let's jump into the main topic, like what is Waterfall, and please highlight some of its key feature to our audience. Sorry, you're muted, sir.
Yes. Yeah, I'm saying yes. Thank you for pointing out on this, and thank you for this question. So yeah, let me start sharing the screen, and we will be very brief because yeah, there could be there are multiple ways how we can describe Waterfall, to the short one and the long one. So we will try to stick to the short one. So. The easiest way to understand what is Waterfall is to review how our testnet explorer works. So this is a visualization of our testnet. Each of these drops is a block, so you can click here, for example, and you can see here the transactions and the references to parent blocks, etc. Basically. What it allows us to do, it allows us to have a concurrent block production and on the later stage concurrent processing, which allows us to achieve very high scalability, but at the same time preserve all the standard of Ethereum virtual machine and very low node requirements and very high decentralization. So for us to basically, let's go to the docs section, docs.waterfall.network, and we can get here to the. So first of all, you can go ahead here and basically you can connect to the network using using this RPC nodes. Here you can use MetaMask. Basically on faucet you are able to receive your testnet tokens. Then basically here are tutorials how you can set up the apps. So this is a one-click setup, so-called one-click. You need to make more than one click, but in general it is like a one-click setup. And here you can use Docker. This is more convenient for server versions. Here you can go ahead and use smart contracts using Hardhat, using Remix, using Truffle. There are examples for WRC20, which is basically almost identical to ERC20, and WRC721, which is identical to ERC721. And also here you can, if somebody is willing to deploy DEX, and by the way, yeah, we don't have DEX right now on Waterfall, you can go ahead and deploy your version of Uniswap v3, and you can improve it, and you can become the first DEX on our network if somebody else hasn't yet deployed theirs, which we are not aware of. So when I'm saying we don't have DEX, we don't have DEX owned by community. So obviously to test the functionality of Waterfall, we were deploying Uniswap. We just took open source code and deployed it, and here you can basically you can test it. We also did the same with Aave. We also did the same with Curve Finance. So it's pretty straightforward process because we're using like actual EVM, so you can just copy and paste smart contracts. You of course will need to change some addresses to smart contracts. You will need to connect the front end, but in general it is like, it's very different than when you need to develop the dApp from scratch. So now about testing results. So we started our testnet, first testnet in October of 2021, presented it in Dubai. At that time we got to around 1,000 transactions per second. And there was testnet number 2, where we basically reached the scalability of around 2,000 transactions per second. Here is the number we reached. And there was a lot of testnet 3, testnet 7, testnet 7. Now, by the way, public test of testnet 7. So somebody, not us, sent 2 million transactions to the testnet 7, and yeah, the network handled it, without delays. And honestly, what is good about it is actually that these transactions were included in one block in the slot. The rest of the transactions were happening in parallel. So basically, we haven't had a delay on the transactions which are happening concurrently with these ones. So for example, if you remember the time with Ethereum when they released CryptoKitties, you could have sent a transaction in the morning, and it is good if it will be processed in the evening. And this is because of the linear structure of the blockchain. In our case, because we have parallelism, even if there is a long queue of transactions, we still are able to process transactions concurrently by adding them to other blocks. At least in this case, it was like that. And by the way, at that time, approximately some other protocols were suffering. I believe somebody was going and testing it, also like approximately the same number, and they, by the way, had a delay. So this is an advantage of utilization of direct acyclic graph. So the last test is actually testnet 8. So in testnet 8, we were able to achieve like more than 11,000 transactions per second. And also, I would like to point out to the node requirements. We're using 2 virtual core CPU and 4 gigabytes of RAM. Basically, 2 virtual core CPU is 1 physical core CPU. So your smartphone, for example, has from 4 to 8 core CPU and from 8 to 32 gigabytes of RAM. So basically, our node requirements are multiple times lower than those of the smartphone. So obviously, yeah, we should say here that cores of the smartphone are not the same as cores of the server, but you know, when you have 1 physical core here and 4 physical cores here, so there could be some comparison, and this is why we are building we are optimistic in saying that, yeah, at some point, Waterfall is planned to work with mobile devices, so portable devices, including smartphones. So yeah, that's what we have. Also, speaking a little bit about traction, we have docs and waterfall.network. So no, not docs. 1 second. Stats at waterfall.network. That's the waterfall.net. So basically, this is the page of statistics. You can find here. So first, the total number of workers, right? Worker is a block producing unit. It is 2,658 workers. And in parentheses, this is the number of workers added in 1 day, which is like 6. So 2,048 workers are controlled by development team. So we are disclosing it here. But the rest of them, which is already more than 600, is controlled by not by us. So it is a community, it is early adopters, it is some testers, it is developers. So basically, we have 600 block producers controlled by the community. So this is what we have as of now. Here also you can find the basically the links to the one-click setup node. Here is the reward ratio, but we need to say that this is not incentivized testnet. So basically, these rewards they are worthless, and they will be basically they will cost nothing. And here we and they're not planned to be traded, exchanges or whatever, and or somehow utilized on the mainnet. And yeah, here you also can find a lot of statistics. I will not go through this. But yeah, 600 block producers. Also, I have to mention that one node can have multiple workers set up on it. But still, 600 workers on not incentivized testnet. We appreciate the attention from the community, and we are trying to do our best to deliver the best quality project for community to start using it soon. I think this could be it, and we are happy to address any other follow-up, any other questions if you have them.
All right, thank you so much for such a wonderful presentation. I think our all the listeners love hearing so far about the waterfall. So I think I have some list of questions which are very interesting. So I would love to know those answer of that question that I have actually. So one of the question is. Uh, this question says like the waterfall mention are directed outlet graph framework. So can you explain like how the DAG is integrated with their blockchain and what specific security benefit does it offer compared to the traditional blockchain approaches?
So yeah, thanks for this question. So basically, let me pass it over to Evgen, where he can provide some light on how we're using DAG on basically on the shard network and how we're planning to use DAG on coordinating network. And then we will, and then I will add something to this question.
Okay, can you see my screen with a dark figure?
Yes, yes, we see.
Oh, great. The dark ledger design can be considered the next generation of blockchain technology, able to solve the scalability problem while preserving decentralization. Unlike blockchain technology with linear sequenced blocks in block database system, the timeline is composed of distinct slots, each of which can have multiply blocks, or are depicted on this figure. Those blocks form referential structures since they must reference several previous blocks. On the Waterfall platform and other networks of similar type, as a result of operations, the created blocks of transaction line up in a DAG, part of which is topologically sorted and finalized. We call this part of blocks stream. Since since finalized blocks of the same slot are created in parallel, it directly affects on the current level of scalability. So this approach helps us to solve the scalability problem and adding a lot of transaction in our throughput. Thank you. Thank you for question.
Thanks, Evgen. And I would like to add that also we are working on the implementation of the DAG on coordinating network. And this essentially, Evgen, would you like to say something about virtually unlimited sharding approach?
Okay. Yes. Right. 1 minute. I will speak without figures. So our research team have just finished working on a brand new approach, allowing us to implement virtually unlimited sharding on the Waterfall platform. Our method intends to overcome the limitation of scalability, preserving full decentralization. Results were submitted for publication. Now we keep on working on the system design and adding new features to our system. The main idea is the coordination network is work as a DAG, as well as each shard network is working, have also a DAG structure. Thanks.
Yeah, so basically, in simple words, we are using DAGs on two levels, and utilization of the DAG brings the concept of parallelism. And we implement the parallelism on multiple levels. So on the level of coordinating network, on the level of shard network, and which essentially can lead us to parallel processing leads us to the parallel processing on the shard level, and then to the parallel processing on the multi-shard level. And all of this because of the DAG. So the contribution of the DAG is mostly to the allowing us to push the boundaries of scalability forward, and that's what we do.
All right, yeah, got it, got it. And people, if you want to know more about the waterfall, please check out their documentation, can say white paper and website, etc. You will get more deeper information over there. So, moving on, I have another good question for Mr. Sergey. So, please give your opinion or your answer. Like, while waterfall emphasize low minimum hardware requirements, some might consider it step towards dedicated proof of stake. So, can you address this concern and elaborate on like how Waterfall maintains the balance between decentralization and efficiency?
Yeah, thank you for asking this question. So basically, uh, it might be a little bit confusing, but I will explain. So we have Waterfall is kind of a pure proof of stake. So basically, it's not like some limited amount of people have nodes, and then some other people, bigger amount of people, stake their coins on behalf of their node. So in our case, everyone can have a node, and node has fixed amount. So in a sense, model is very similar to Ethereum. The second thing is actually that what we are doing, we do have a delegation mechanism, but this delegation mechanism is more for like a security purpose. For example, if I have, I don't know, very large number of water coins, right? For different reasons, liquidity, whatever, the different use cases, or I just decided to significantly contribute to the security of the network. So, and for example, I would like to stake them, but I need to stake it on multiple servers, creating multiple workers on each server. So, for me to do this, I'm able to, without transferring, for example, for me to do this, I'm able to do without transferring it on the hot wallets of these nodes. I can just post a staking transaction, which will stake it, which will use the coins I have on my cold wallet on these nodes to stake them and produce blocks. It is also very helpful with, for example, with infrastructure providers, which will be providing the node infrastructure services for those who are not willing to host the node themselves. So it is becoming kind of non-custodial staking. So basically, they have a server, the coins delegated to this server to produce blocks, and then the rewards are somehow distributed. I mean, of course, if it is not prohibited by their jurisdiction, by the laws of their jurisdiction, but yeah, in general, this is how it is done. So delegation in our case, it's more like a security measure, and Waterfall is a proof of stake. And yeah, by the way, soon you will see a lot of announcements. I mean, multiple announcements about partnerships with different node infrastructure providers to improve the user experience and the quality of the servers provided for our community, which are not, for different reasons, may not want to store their nodes on their computers. Yeah, thank you.
All right, yeah, got it, got it. So thank you so much for the clarification. Now I have another question for Mr. Alexander. So this question says, like, can you elaborate on the technical trade-offs involved in this approach, and how does it impact network security and decentralization compared to more resource incentives full nodes? You are muted, sir.
I'm sorry, I don't understand full questions. It's about requirement of our nodes.
Yeah, let me repeat the question. Like, This question says like, can you elaborate on the technical trade-offs involved in this approach, and how does it impact network security and decentralization compared to the more resource intensive full nodes? I think this question
Maybe
is
Sergey will
little,
help me.
yeah, I think we need to rephrase this question. This is a little confusing
Please, yes.
question. Yeah. Okay, let me contact to the owner. Okay, other than this, I have another question. Like, is there a whitelist for buying your token?
Yeah, well, this is again, we are a technical team. This is a very frequent questions. How to buy coins when they will be released, etc. So we work on the technology only. So people can join our communities. There they can reach out to Richard Wang, who is a general partner of Rapid Dragon Fund, or Brad Xu, who is actually an investment director for Waterfall. And they can ask these questions to them, and also they can write to them to investor relations at waterfall.network or ir.waterfall.network. So, yeah. Well, and honestly, previous question sounded interesting. Can you please rephrase it? And yeah, I will try to help maybe addressing this.
Okay.
I have these questions. You sent to me in text version, and I don't hear and understand about it. It's about decentralization, and a lot of people who work on decentralization projects, he know if we have more decentralization, we should have a more research, more. We should have server or nodes with high requirement. So, but we use parallel, and a lot of tasks which do nodes. This task do not does with in parallel, and some task work one node, other task do other node, and for example, we have committees, and some workers in committees send each other attestation about information. This attestation then aggregate, and the only aggregation information sent to global network, global our network. So we split some algorithmics on the small parts, and these small parts do only one nodes, and the second parts do other nodes, and then results contain and voting by global members in network. So and it's we so it's and also we have a mechanism which if worker or not work badly, and she maybe do some mistake or errors for our network, and other workers nodes can introduce this information, and worker who works doesn't good, he will get penalty. So and so it's also our solution to add more security for our network.
All right, thank you so much for highlighting the solution to increase the security in Waterfall. So, other than this, like, I have another question. Like, what measure has Waterfall implemented to ensure maximum decentralization?
Well, there are multiple ways how we can see this. Our job here, and we can go to this, so-called Nakamoto coefficient. Basically, Nakamoto coefficient is the number of entities which can collude to actually terminate the work of the network. So this could be reviewed from different perspectives. So, for example, let's say we have a lot of nodes, right? But all of them are set up on Amazon. Then Nakamoto coefficient is becoming 1, or if it is like Amazon, Google, and Microsoft Azure, so the Nakamoto coefficient is becoming 3, because all these three entities can collude and they can affect the work of the network. Similar situation happened with Bitcoin, for example, in I think in 2017, 2018, there was top three mining pools were controlling more than 51% of the network, and all of them were located in China. So in that case, Nakamoto coefficient could have been 1, because Chinese government, for example, can shut it down, or it could be 3 because all three Chinese all these 3 pools can collude and do this. There are also different angles how we can understand this, because it is about the ownership concept, and basically, for example, let's say nodes are different, but the owner is the same, and basically, yes, it also reduces the Nakamoto coefficient. But let me put it this way. Our job here is to create a very decentralized technology which is able to combine scalability and decentralization on the level of having millions and potentially more block producers. We are also working with KYC providers then later on to enable the basically the verification of the ownership, and it is going to be involved in the DAO. So we have on our website 1 person, 1 vote. So in that regard, the DAO is planned to work. Usually, like some DAOs work like this. Basically, say a person who owns more coins have a higher vote. And in that case, it is becoming the kind of like the governance of enterprise, right? So basically, the more voting shares I have, the stronger is my vote. When we're talking about democracy, we are having, it doesn't matter. I mean, in ideal world, it doesn't matter whether I'm rich or poor. I have 1 vote, and I am using this vote. What we do have also in democracy, in democracy of the countries, we have it is so-called delegated democracy. So basically, I do not vote for every decision of the government, but I vote for people who are making these decisions. And we're going to implement, depending on the particular case, there are multiple levels of understanding this from the perspective of the game theory. So, for example, directed to voting may be related to the grants. Let's say people can vote for which applications they are going to use. And yeah, this is here you can have, like, say, a direct democracy. For example, when we're talking about more complicated aspects of this, let's say the upgrade of the protocol, right? There should be, so of course, the community voting. And second, there should be certain expertise, expert committee involved who are making this final decision. Because sometimes when you are implementing the direct democracy, it is becoming vulnerable, for example, to the game theory problems like tyranny of majority, and also if majority are not experts, and we are aiming to achieve very high decentralization. So not only like highly technical people own the node, but regular people also contribute to the security of the network. So in that case, there may be some expert committee. So this is not yet strictly decided, but we're going to push it significantly further. And with implementation of the mobile devices, we can get to potentially even higher numbers than the ones I named. So yeah, that's the task we're solving. How to combine scalability good enough for mass adoption with decentralization, which is able to cover big number of independent participants.
I would like to add more one time that preserving decentralization is very important for us, not only a high transaction throughput, all what our team do, we do in assumption a very high level decentralization of our system. In doing so, first we developed a new fast finality proof of stake consensus protocol involving the participation of millions of nodes. Second, especially scalability in terms of transaction processing capacity. Also, we work on parallel processing, reducing execution, data traffic, and data storage. Thanks.
Okay, yeah, got it. So, other than this, can beginners set up a test node, and or is it more for tech savvy? What's your answer on that?
Maybe I will share screen and fastly show about see you my screen?
Yes, we are able to see that.
It's our website, yes? Waterfall network.
Yes.
You see? Yes. Okay. So you can a few ways to download our application and not. You can go to our website and click to join testnet, and you can download in the bottom. Also, you can go to the documentation for our site, and we have tutorials, and you can download application. We have two versions to install. You can install Docker and launch our application, our nodes in Docker. It's for more professional user, but but we have a good instruction and a lot of beginners users by these steps can install and run our node, because we have these versions in the first. Second way, you can go to our and download our native application called on-click setup. You can download for your computer, RAM or Intel, for Mac or Windows. So after we can download, and after that you can launch application, and it's our on-click setup application. Now I have one node, but application haven't launched it before, but and now in thinking. So for firstly, you should add node and select type. Now we support only local node. It's located database in local disk. So you have to use SSD. So Select network. Now we have only testnet 8 located data folder. When you want to save database, for example, mm, and we have to way next. You can put checkbox for download our last snapshot. It needs about 70 gigabytes, but we need more space on this because you have download this snapshot and then extract because it's archive. But you have free 150 gigabytes. But then we use about 80 gigabytes. But if you don't check this checkbox, you will synchronization with from Genesis, and it spent a lot of time, maybe 3 or maybe more days. We will on this week we will check how many time we need to full synchronization from Genesis. So if you don't have time for that, you can download a snapshot from us. We deploy this snapshot about once a week and deploy to upload to Google Disk, and you can download from there. So then you should change its port because I already have one node. So and this port in use, and you can see you should change them. And because you can have conflict if you use the same ports for two nodes in application. So after that you should set a name of node and information about, and then you can add. And we now are creating nodes, and node is creating, and now we have status downloaded. It's because download snapshot. So after information, it's empty because not doesn't run. So second step which you should do, it's add worker for add a worker. We also have next steps in illustration what we should do for setup. You can read instruction and see screenshot. But I know we have video about it, but I don't know who uploaded video to YouTube or no. So back to our application. So you can go to workers for this node. You can add or import from other computer or add new worker. Also, you can do this in tab workers. Also, you can do the same. But I recommend more do it in workers in nodes because you don't have mistake which nodes you use. So you can select at worker. You should we generated mnemonic. You should save this mnemonic to safely storage. Copy. Then you go and you should confirm which your mnemonic. So
Sasha, Alexander right now is showing how you shouldn't use your mnemonic phrase. You should never show it on the screen to anyone. Never ever show your mnemonic phrase to anyone. So Sasha currently quickly showed. So this is how you shouldn't do, and now he's switching to the how you should do it. So yeah, don't ever show or share your mnemonic phrase to anyone.
Yes. Thank you, Sergey. So now, how many? Then after verify mnemonic, you can choose how many workers you want to add. So maybe 3, maybe 2, and your withdrawal address. My withdrawal address. I will check. So, for example, for that, yes, I will use. So now this withdrawal address, if mnemonic phrase, its mnemonic phrase need to generate a case for your workers, but and these workers these workers should create blocks and sign by this case and create attestation and sign attestation. Yes, and if you have problem with workers, you always can deactivate these workers and create new. So, and if you lost mnemonic, it's you can't add new worker for this node, but you can always deactivate these workers because you will use this withdrawal address for that. And then you can remove workers from nodes and create new, add new. So it's not problem if you lost mnemonic phrases. It's a problem, but it's not security problem. I mean. So now we added 2 workers. So yes, now we have 2 workers. My nodes now in still synchronization. So after synchronization, I will have enabled this button activated worker, and after that you can send transaction to activate it, and then a worker will work. So that's all what I want to show about for beginners. I think it's not hard. So for beginners, it's maybe easy steps to run launch our nodes. Thank you.
Yeah, indeed, these are the easy steps. Or I think you must have some tutorial also on this regard, so that people can interact more, like how they can create nodes and all this stuff. Okay, so other than this, let's move on to another good question. So how does waterfall decentralization compare to traditional blockchain model?
So well. Basically, again, I will still get back to the screen. Waterfall testnet explorer. 1 second, I will load it, and then I will start Explorer. So yeah, the Explorer is running, and yeah, now I'm sharing the screen. So well, so yeah. Basically, that's a good moment. So, for example, if you would visualize the blockchain like this, you will have just a straight line like here. You see, one block happening after another, and so on and so forth, basically. This straight line. And in our case, we have parallelism, which allows us to enable the kind of wider the subnetwork concept, which Evgen mentioned, is a concept which allows us to split the nodes to, let's say, strongly connected subgroups which will be able to create one or multiple blocks concurrently with other subgroups. And this, for example, how you can visualize this, you can have nodes, I don't know, in United States, you can have nodes in India, you can have nodes in China, you can have nodes in Europe, and then each of them creating one or multiple blocks and basically merging them into the same tag. This is the concept we are working on, and this allows to have like a parallel processing on the single shard level, and it allows to accommodate large number of nodes, but at the same time preserve scalability and low node requirements. So this is how DAG is helpful, and we sincerely believe that the DAGs are the future of distributed ledger technologies, because like blockchain, they have this trilemma, like scalability, security, and decentralization, which essentially boils down to be a dilemma between between scalability and decentralization. Because if you don't have security, you don't have fintech. Obviously, there could be different types of security, like probabilistic or deterministic. And by the way, Waterfall combines both of them. We have high level of confidence that, I mean, we already were able to push scalability and decentralization to the very different degree than this is, let's say, common on the market, and we are going to increase it, to push it forward going forward. Yeah, thank you for this question.
All right, yeah, got it. So I think now I have last question for you. Like, how energy efficient is the Waterfall protocol compared to the other block DAG protocols?
So, well, let me put it this way. There are, speaking of energy efficiency and node requirements, they are somehow somewhere near. So, generally speaking, there are block DAGs and good block DAGs, but which are on working on the proof of work. And obviously, they consume more energy the same way Bitcoin is consuming more energy than, for example, proof of stake consensus algorithm. So we're using proof of stake with low node requirements, but it is designed to have big number of nodes. So proof of stake are generally considered energy efficient, and we are pushing the node requirements lower to decrease the energy requirement for protocol to function. So yeah, and all of these measures, which are may make it sound a little bit more complicated, like this dark here, dark there, etc. This is the move in the direction on how to make it low node requirements, high decentralization, high scalability, doing it all together. And if you will review the average number of nodes on the protocols, and yeah, let me actually show you. Let me show you on the screen. 1 second. So yeah, we're almost here. Yeah, okay. I start sharing the screen. Basically, here you go. So this is the number of block producers on the popular networks. And first two are more than 100,000. Ethereum is almost 1 million. Bitcoin is less than.
I don't wanna say anything, cause if I don't wanna say anything, cause if I do, I might say the wrong words. Oh no. So I'll keep my mouth shut and not listen. Afraid I lose you if I didn't. Can we find what we're missing and compromise? So I'll keep my shoes on and not leaving. We're on thin ice, winter season. Can we find a single reason not to say goodbye? Oh, if I said what's on my mind, would you stay with me tonight? If I said what's on my mind, would that make you run and hide? Run and hide. Run and hide. If I said what's on my mind, would that make you run and hide? Would that make you run and hide? Run and hide. Run and hide. Oh, would that make you run and hide? Don't know what to do anymore. I'm out of options, nothing's working. I'm out of service. Come help me now, I'm fucking nervous. I'm trying but can't scratch the surface. So I'll keep my mouth shut and not listen. Afraid I lose you if I didn't. Can we find what we're missing and compromise? So I'll keep my shoes on and not leaving. We're on thin ice, winter season. Can we find a single reason not to say goodbye? Oh, if I said what's on my mind, would you stay with me tonight? If I said what's on my mind, would that make you run and hide? Run and hide. Run and hide. If I said what's on my mind, would that make you run and hide? Would that make you?
Okay, sir. Could you please start again with the same presentation?
Yeah, sounds good doing it. So yeah, basically something we were addressing that basically here is the number of block producers, right, for popular protocols. So for example, we have Ethereum, which is close to 1 million. Gnosis is more than 100,000. Then Bitcoin is in this number of nodes, like 50,000, and all the rest are actually measured in thousands until here and until number 8, and these are already in hundreds, and going forward it is already in tens, like 17, 63, 58, etc., and so on and so forth. You can review this talk on my LinkedIn, and basically what it means that in most of the cases protocols are making choice in the favor of scalability with some sacrifice to decentralization. And by the way, I'm not saying these are bad technologies. These all are good technologies. But what we're trying to do, we're trying to achieve both. We are trying to achieve high scalability and high decentralization, measured in millions and maybe more. Also, as long as we are already watching, looking at my LinkedIn, I would like to share one important announcement we have. So basically, yes, we're preparing for the launch, maybe even next month, and we're forming the ecosystem. So we already have close to 10 partners already signed up, and we are having a good traction on this topic. So we're inviting bridges, oracles, digital identity providers, liquid staking, staking infrastructure providers, DEXs, lending protocols, gaming apps, NFT, stablecoins, and wallets to partner with us. Other applications are also welcome. Please join our community channels and follow the announcements. Again, we look forward to having you all on our launch, and we hope you will join the exciting journey of building the Waterfall and its ecosystem.
All right, yeah, got it. And I think we covered most of the part of the project, and it's time to wrap up. So before wrapping up, do you want to say something to our community or offer us a closing statement? You can please go on.
Colleagues, you would like to start? Okay, let me then go. So basically, yes, we are inviting everyone to join the testnet and prepare for the launch. If you experience any bugs or you don't, some inconvenience in the process or something doesn't work, please report back to us, because this way you are contributing to the development of the project. Also, if you are a developer and you are looking to deploy your dApp on new technology, on new protocol, please go ahead and do that. We currently have already more than 45,000 people across our community channels, and association. I'm telling this is association community channel, and association hasn't been doing any airdrops or something like that. So it's not like the community of some fake users. These are users who are coming when they are learning about our technology. They are highly engaged and highly enthusiastic. And basically, yeah, by deploying your dApp, you can go ahead and get your these users to use it. So we are welcoming and we're open to collaboration opportunities, and everyone is welcome to join. Thank you so much. Oh yeah, this is what we have to say. Yes.
Okay, that's great. Okay, so guys, please support Waterfall Project, such a wonderful team member, and be the part of this community. And if you have more question or need any assistance with anything related to the Waterfall, drop this question on their social links. Their community manager or their lead member will definitely reply you. And yeah, that was it from today. See you next time. Have a great day. Bye bye.
Thank you so much. Thanks for having us.
Yeah.
Have a good one. Thank you. Bye.
Bye.
I don't wanna say anything, cause if I do I might say the wrong words. Oh no. So I'll keep my mouth shut and not listen. Afraid I'd lose you if I didn't. Till we find what we're missing and compromise. So I'll keep my shoes on and not leaving. We're on thin ice, winter season. Can't we find a single reason not to say goodbye? Oh, if I said what's on my mind, would you stay with me tonight? If I said what's on my mind, would that make you run and hide? Run and hide. Run and hide. If I said what's on my mind, would that make you run and hide? Would that make you run and hide? Run and hide. Run and hide. Oh, would that make you run and hide? Don't know what to do anymore. I'm out of options, nothing's working. I'm out of service. Come help me now, I'm fucking nervous. I'm trying but can't scratch the surface. So I'll keep my mouth shut and not listen. Afraid I'd lose you if I didn't. Till we find what we're missing and compromise. So I'll keep my shoes on and not leaving. We're on thin I don't wanna say anything, cause if I do I might say the wrong words. Oh no. So I'll keep my mouth shut and not listen. Afraid I'd lose you if I didn't. Till we find what we're missing and compromise. So I'll keep my shoes on and not leaving. We're on thin ice, winter season. Can't we find a single reason not to say goodbye? Oh, if I said what's on my mind, would you stay with me tonight? If I said what's on my mind, would that make you run and hide? Run and hide. Run and hide. If I said what's on my mind, would that make you run and hide? Would that make you run and hide? Run and hide. Run and hide. Oh, would that make you run and hide? Don't know what to do anymore. I'm out of options, nothing's working. I'm out of service. Come help me now, I'm fucking nervous. I'm trying but can't scratch the surface. So I'll keep my mouth shut and not listen. Afraid I'd lose you if I didn't. Till we find what we're missing and compromise. So I'll keep my shoes on and not leaving. We're on thin ice, winter season. Can't we find a single reason not to say goodbye?